So welcome at Codecamp, Scott.
Thanks for having me. I'm super excited to be here. This is like my last conference and my last session of the year as well. So
I think we're all ending the year in a positive manner, all prepared for Christmas and with high hopes for the new year.
I cannot wait for things to get back to normal and to be able to do these things in person. I really would want to do this next year in person. So
fingers crossed.
Fingers crossed. Yeah, we feel the same. So Scott, how is it to be the director of program management for .NET and many other things? So in a way, we feel like we as .NET developers, we feel like our life depends on what you're doing there.
My journey is kind of a weird journey. For people that don't know, I joined Microsoft in 2007. I joined the ASP.NET team. So I was a big web developer and came onto Microsoft to be part of the ASP.NET team. I can show something really funny that'll surprise a lot of you. Let me bring up something if I can share my screen as well. Mm-hmm. And in the ASP.NET team, we got lucky. We got moved to Azure in 2010. So Scott Guthrie, who we reported to, he went to Azure in 2010, and we went over there with him. And that was kind of good for us because it meant we got to think about, hey, how does the cloud work and how does .NET work in the cloud? And today we're going to talk about .NET 5, but a lot of folks don't even realize, how did .NET Core, which was the predecessor to .NET 5, even happen? And so let me show you something kind of cool here. Many people have seen this. This is and I'll share my screen here.
Yeah, just a second. So we can also put it live.
When they can see it.
Yeah, it's live now.
Yeah, so if you look at this slide says Project K. That was the code name for what became .NET Core, the reinvention of .NET. And look at that date, July of 2013. So we had thought about this just about 3 years after we had moved to the cloud. We were thinking about how to reimagine .NET in the world of Linux and Windows and open source. And so this was the actual original slide deck that we presented to Scott Guthrie, kind of the father of .NET. We were asking permission to reboot it into what became .NET Core. And so this is the initial slide saying it's a lean composable .NET stack, small core CLR. I don't even know if the word core CLR existed at that point in time, but maybe we invented it. Ecosystem of packages, very simple packaging, versioning rules, true side-by-side, not a Windows component. The funny thing about this is, and this just shows the era of Microsoft, that we presented this in. Notice it doesn't say open source and it doesn't say cross-platform. We presented this to Scott and Jason Zander. Jason Zander runs Azure. And Jason was like, why is it not open source? Why is it not cross-platform? But as we talk about .NET 5 and kind of the reinvention of .NET, a lot of that really started when we were in Azure. The ASP.NET team was in Azure back in 2013. And then, we publicly started talking about it around 2016, 2014 actually. So that was about a year before developer division, where I am now, decided they were going to give us a core CLR, which was the cross-platform building block for .NET Core. And so what happened was around that time, developer division asked me to come over to developer division and run the .NET team from a PM side. And so I left Azure, brought the ASP.NET and the web tool bits with me over there, and we put together a new .NET team in 2016. And all the bits that you guys get to play with and try today, that's kind of how that journey started.
Brilliant, quite a story. So it looks like 7 was a lucky number for the .NET future. Brilliant. Okay, so you've got the floor.
Awesome.
And
then we get back together at the end of your session, and we can discuss more.
Sure. I'm actually off work for the rest of the year, so if we want to go a little bit long and talk about the history, talk about how we got here, I'm happy to do that afterwards.
I'll just take the opportunity to remind our audience that they can ask questions and get answers directly from the source, so to say. Okay.
Cool. Okay. I'll try to go through this pretty quick. I've got a lot of material here, and I'll try not. I've got more demos than I could ever do, thanks, Jimmy, for showing a lot of the API stuff, and maybe I'll skip some of the API stuff because he just did that. But folks that just kind of heard, I'm Scott Hunter. I'm the Director of Program Management at Microsoft on the .NET team. And so my team and a pretty big engineering team is kind of who's responsible for, .NET Core and the .NET 5 that you see today. And of course, we still work on .NET Framework too. We just shipped .NET 5 on November 10th. And it brought a ton of stuff with it. It brought single file applications. It brought a bunch of web and cloud investments, which I'll talk about in a little bit. We got a lot of feedback after we shipped .NET Core 3.1 that we need to do more for the desktop, and so we did more for the desktop. With the Apple M1 Macs, there's a lot of talk about ARM64 right now, and so we actually put support in .NET 5 for Windows ARM64. And then early in 2021, we will ship Winforms and Wpf on ARM64 as well. So you can build ARM.NET applications that run on Windows devices. We already support ARM64 for Linux and Raspberry Pis and stuff already. A huge round of performance improvements again, and a bunch of language features. People always ask me how we're doing as a framework. We shipped .NET Core, the first version, really in March of 2017. So it's been about a 3-year journey, a little bit over a 3.5-year journey at this point. We have, even though the slide says 2 million, it's really about 2.2 million. So we've created 2.2 million .NET Core developers in those 3 years. On Stack Overflow's developer survey, we've been the #1 most loved framework 2 years in a row, 2019 and 2020. And even though we open sourced very, very late, we open sourced in 2014, things like Java were open source, 10 years before. We are one of the highest velocity OSS projects. That's looking at, issues, pull requests, comments, PRs. That's just the activity that you see in the repos drives us up there. We're the number 5 language in GitHub. And in the Tech and Power benchmarks, when it comes to raw plain text, we've been #1 for a bit. If you look at .NET all up outside of .NET Core, we have over 5.2 million .NET developers today, which is pretty impressive, I think, considering the longevity of the framework. We shipped the desktop support in .NET Core 3.1 a year ago. We've already had 200,000 of our developers move over from .NET Framework to .NET Core with their desktop applications. Just in September, we added 230,000 brand new .NET Core developers. So you can see we see internally at Microsoft this pickup of the frameworks growing faster and faster. And even though we just added open source, and Linux in 2017, we're now seeing 2 million publishes per month in our tools to Linux. So it shows that embracing Linux was important, and our customers are using it. I'll jump through some of this a little fast. When it comes to performance benchmarks, this is showing ASP.NET Core 3.1. This is something we shipped a year ago, and it shows the plain text benchmark. And this is using a flavor of the benchmark that the team at Red Hat did. This is running on Red Hat Linux, and you can see it's 7.3 million requests a second, and that's faster than pretty much anything there. Let's take a look at what happens with .NET 5. That plain text jumps from 7 million to 11 million. So you're going to see a 38% performance improvement just for moving from 3.1 to 5. JSON, our JSON performance in Tech and Power improved 42%, up to 1.2 million requests per second, and that puts us ahead of Java, which was our goal in .NET 5. And then finally, Fortunes, which is the most realistic benchmark in the Fortunes, in the Tech and Power benchmarks. You can see we're doing about 417,000 requests a second, which is up 20%. And that's a real world app. That's producing HTML. It's talking to a database. So that's more of what you would expect in your applications. But you can see, even from 3.1 to 5, huge performance improvements. If you have not even touched .NET Core or .NET 5 yet, each version has these level of improvements. And it doesn't stop there. If you look at Linux performance, you can see we made our sockets 30% faster since 3.1 on Linux. JSON serialization, once again, up 20%. And then serialization of large collections and arrays is 3 times faster, zero alloc. And then the one that I think is the coolest is gRPC, which is a modern kind of replacement for something like WCF. It's cross-platformed, cross everything, and we are likely the fastest gRPC server on the planet. You can see that we're faster than Go, we're faster than C++, we're faster than Java. At the time we did this, we had not shipped yet. We think we might have even passed Rust. So if you choose .NET, you're on fast tech. Let's talk about Windows Desktop. We shipped this for the first time in .NET Core 3.1, and what we've done since then is we've finally finished the designers. So all the controls that we're going to put in the WinForm designer are now in the WinForm designer. We've added ClickOnce. That was the biggest feedback we heard from our customers after we shipped 3.1 was we want that ClickOnce installer, so it's back. And we're just now starting to see third-party controls light up and work in the designers as well. Now, you get a huge bunch of benefits if you move your desktop app to .NET 5. You get self-contained. This means you can actually build a desktop application that you don't need any .NET on the machine at all. We'll ship the framework and your app together in a single exe. You're going to get better performance, as I showed you, likely 25 to 30%. And now we have support for like modern controls like WebView 2. And with that, let's do a quick desktop demo. So I'm going to jump to my Visual Studio here. And the first thing I want to show is this is the designer. And there's a couple of cool things here. You probably heard about the new Edge we have that's based on Chromium. And that is now available for .NET applications. So you can see I've got a WebView 2 here. There's just a NuGet package in NuGet.org for this. This means you can actually host a very modern web browser directly in your .NET application, your .NET desktop application app. The next thing that's kind of cool about this app is notice that this has got a rad drop-down list. The cool thing there is if I look over here, I can see Telerik UI for WinForms. So we now have support if you're using the Telerik controls. They show up now in the designer, just like the built-in controls in .NET. And this has been a journey for us. I mean, if you're a .NET Framework customer, we've had the designer working for years, decades. But if you're a .NET Core, now a .NET 5 developer, it's been taking us a while to get all that functionality to work in this world. And so let's run the app for fun. I'll close the designer out. And before I run the app, let's go make a few changes here, and I'll show some cool other features as well. So this is a Goo-Hoo-Ha is basically a Scott Guthrie, Scott Hunter, Scott Hanselman application. So we need lots of Scotts. And so you can see I've got my class here. It takes a constructor. It's got the properties. And so I basically make a collection of Scotts. Let's data bind this. And now if I run the application, what I'm going to get is an app with a drop-down list from Telerik. And then what I can do is I can, it'll show the Twitter page for each of the Scotts using that modern WebView 2. There you go. You can see it works. Let me show you a C# 9 feature that's really cool. We all have lots of this stuff where all it is a bunch of properties and a constructor. Well, we have a feature called records in C# 9. And so I can take all that, I can make that go away, and I can replace it with just a single line of code. All it is public record. I give it the name, and then I give it a constructor technically. It takes a name and it takes a Twitter URI. And from that, we'll generate the properties for you. And so that huge class declaration before that was roughly 9 lines of code, now is 1 line of code. And I know that all of you have lots of apps where you just have files and files of those classes, and you can literally replace all those with a bunch of single line shortcuts. And so app should still work exactly like it did before. That generates basically the same code as the class did before. It's just way more concise, and that's one of our goals with C# 9 is to make this stuff even better. I want to right click over here and show another thing that we've done, and that is I can click publish, and I'll say folder, and now you're going to notice ClickOnce is back. So I can click once. It'll bring up a wizard where I can do a lot of options here. What this technically does is it builds an installer for your project, and the installer supports even things like auto updating. So basically, you run this wizard. It'll generate a ClickOnce installer for you. You give a URL to your anybody wants to run the application, and they just click the shortcut on their desktop. It goes to the web, checks if they have the latest version, installs it, runs it, and we brought that forward. That was the most requested feature that we had from .NET Core 3.1. And with that, we'll jump off the desktop for a second. Mobile is always a big thing for us, and I'll talk a little bit about mobile in later today as well. Xamarin Forms 5 ships this month, and it has amazing support for making beautiful apps with new brushes, shapes, and paths. We have now taken the XAML experience. XAML is, what a WPF app is or a Xamarin app is, and we now have the exact same designer across both of these technologies. So as we make WPF better, we make Xamarin better. As we make Xamarin better, we make WPF better. We've also got Hot Reload too, and Hot Reload is a really cool tech. Our job is to make you be able to build these apps faster and faster. And so what Hot Reload does is, as you change your XAML, we refresh the app live. So you can just sit there and change the XAML, kind of like you would as a web developer, and then you'll see it live on your device in real time as you work on it. And even cooler, a lot of people don't realize this. We've got tech in the Xamarin stuff as well now, where anybody on a Windows PC can basically plug an iPhone or an iPad in and just hook it to the computer. You don't have to have a Mac. You have to have a developer account, and you can publish right from your Windows device to your iOS device, live right from Visual Studio. You will need a Mac to actually publish to the store, but it means all the development can be done locally without any special requirements, which we think is really, really cool. And with that, let's jump to Visual Studio for a second. So we just shipped Visual Studio 2019 16.8 back on November 10th. And we shipped the preview of the next version of 16.9. This is important if you want to use .NET 5, because it's the one that has .NET 5 inside of it. It's got support for .NET 5. It's got a ton of other productivity improvements and telecode improvements. The ones I want to highlight today is I want to highlight our new Git experience. We all use source control. Most of us are using GitHub probably, and we're making it better and better for you to use Git and GitHub directly from Visual Studio. We have Linux debugging. This is a big thing to me. As we think about microservices and we think of the cloud, what if you want to develop on your Windows device, but you really want to test against Linux? That is now a simple drop down, and you're developing on Linux live on your Windows machine. To get that today, you need to be on the 16.9 preview. The preview can run side by side with the 16.8 GA. And then we have support for GitHub Actions. So not only can you build an app with our new Git experience, debug on Linux, but we've got great support for doing a CI/CD workflow for your publishing directly to the cloud. And so with that, let me show a couple things here. So I'll go back to Visual Studio. Let's go load that up. And what I'm going to do is I'm going to open up Web App Linux. And one of the things that's important here is I don't have any containers or Docker or any of that kind of stuff running on my machine today. I will later. Normally Docker would show up right here. It doesn't because I don't have it running. I've got a simple ASP.NET Razor page application, and all it does is it writes the operating system out to the screen right here, environment.os version. So let's run this application. And of course, it does exactly what you would expect. It's going to say, hey, guess what? I'm running on Windows. I'm running on Windows 10. Great. Well, what I'm going to do is I'm going to go back, and because I got 16.9 installed, I now have this new entry here, WSL2. And what that stands for is Windows Subsystem for Linux. And if you don't know that, that's a feature you can just enable in Windows. And I can even highlight that a little bit here. I can go over to my command prompt, and I can type WSL. And notice it says welcome to Ubuntu. And now I get a Unix command prompt. I'm actually now in Linux on my Windows machine. So and you saw how fast that launched. So it's amazing. So you can now run Linux natively on a Windows machine. So I can take that drop down. I can select WSL2, and you can see it's doing some checks to make sure everything is looking good. It's trying to make sure that we've actually configured that WSL2 correctly for .NET. And now if I run again, there you go. Now I'm running on Linux. So you can develop locally on Linux just about as fast as you can develop on Windows, which I think is pretty smashingly cool. Let's try something else here. What I'm going to do now is I want to take this Linux app that I built, and I want to get it up into GitHub. So what I'm going to do is I'm going to use the new feature that we have in Visual Studio 2019 16.8, and I'm just going to say I want to create a Git repository. And so in this simple page, you can see it's got my local application. It knows of my GitHub account. It knows my owner. It gave me a name, and I can decide to be public or private. And I'll just say, yeah, create and push that for me. So that's simply, I took my application, I added Git support to it, and I took it and I actually pushed it up to GitHub. And so if I go over to my web browser here, and I look at my repositories and I refresh the screen, there you go, there's my web app Linux. So you see how easy that is. Now I want to show another feature that we have with GitHub. I can right click on my application and I'll do a publish. And let's say we'll do Azure. And let's do app service Linux, because this is a Linux application. There it goes. It found that I already created one of these before. And then something new is going to happen here. We have this new thing called deployment type. And normally we would just create a pub XML file for our publishing. This is called right-click publish. You know, a lot of people make fun of it. Still great for just messing around and trying things out. But there's now CI/CD using GitHub Actions. So all I'm going to do is select that, click finish. And what that's going to do is that's going to drop a file in my application that contains my, and I think I can click edit here and show you what that looks like. It creates this GitHub action file that contains all the necessary stuff for this to create a CI/CD workflow. So because I click that, notice that in my tool down here, it's showing that I've got a change I need to push up. So let's click that, and I'm going to say added GitHub Actions, and I'll commit that, and I'll push it. And you can see it's we're pushing right now. So that's now pushed up. Now, what GitHub Actions is, it's a CI/CD workflow that you get for free inside of GitHub. So if I go back to my browser and I click on this repo, there's a tab here called Actions. Let's click Actions, and because I pushed that file, it's now running a CI/CD workflow to take my application, build it in the cloud, and then take the end result of that and publish it up to my app service running in the cloud on Linux. And so I can click this, and you can see what's going on here. For 23 seconds, it's been running a build. Let's click that build. And you can see it's already done. It grabbed the .NET Core 3.1. It restored some packages. It built the application. I can drill in and open any of these if I want. You can see it's pretty much complete here. This was it doing all the build steps. And so it looks like, from what it says here, it's pretty much done, completed job. So this means that just by committing that code, my app is now running up in the cloud. And so I can go over here. I can go click this. This is the app from my dashboard. Here's the URI for my app. And there you go. Now the app is not running on my local machine. You can see it's running in Azure on Linux, just like it was before. So not only did I debug and test locally on Linux, I publish it to the cloud on Linux as well. So, and this tech is really, really good. If I want to do some local development and not push it to the main, if I create a branch and work in that branch, it'll create a staging site for me as well that does not affect my main site. And then when I make a PR from my branch to the main branch, it'll then publish it back to my production site. So it's pretty cool, pretty well thought out tech. So let's jump back over here. And let's talk about web and cloud, big part of .NET. So we shipped Blazor with .NET Core 3.1 back a year ago. And then in May of this year, we shipped support for Webassembly. Now, with .NET 5, we've added tons of new stuff. The big thing is we've got full support in .NET 5 for Blazor Server and Blazor WebAssembly. Blazor WebAssembly for folks that don't know it, any of the tech in .NET that has to have what we call AOT, ahead of time compile. This is primarily our Xamarin workloads, iOS and Android. We actually compile those to native code before we push them onto the devices. Blazor WebAssembly requires this as well because we're basically running inside of the browser. And anything that uses AOT today is using our Mono framework. We still use Mono in .NET 5 for Blazor WebAssembly, but we've changed Mono to now run on top of the same base class libraries that we do for the rest of .NET. With .NET 6, we will take the Xamarin workloads and move them there as well. And so the goal for our team is to have one set of core libraries that all the .NET workloads run on top of. It's 3 times faster than the previous release. It supports pre-rendering. We all know these SPA applications, you've seen them all. They load up with a spinner. We now actually pre-render them, so they load much faster, and we can lazily load dependencies. So we don't have to load the whole app to get it running. We load just enough to go there. We have component virtualization. This means components can contain the CSS and JavaScript, and component virtualization means you can put huge amounts of data on the screen without actually sending huge amounts of data to the screen. CSS and JavaScript isolation. Now, if you have a component, the component can contain its own CSS and JavaScript, and we can make sure that we ship that with the component. And so with that, let me do a quick demo of Blazor. So I'll go back to my start page here, and I will click the Blazor Net 5. And let me just make sure that here. Okay. So I want to start with this app, and I want to show a few things. Let's go look at the project file. Normally, in a .NET Core 3.1, the project file would target .NET Standard, and that's because we were running on top of the Mono base class libraries, not the .NET base class libraries. And .NET Standard is the one thing that targets all .NETs, whether it's Mono, whether it's .NET Framework, or .NET Core / .NET 5. But now, because of Blazor WebAssembly now runs on the same core libraries as the rest of our technology, you can see that it just targets .NET 5. Now, one of the big things about Blazor that you need to be aware of is if you're running a Blazor WebAssembly app, that is when we actually run the entire app inside of your browser. The browser is actually running your C# code. In that case, you're running in the sandbox of the browser, and so everything doesn't work the same way, meaning you can't do some things. You can't touch the file system. You can't read the console. We didn't really help you find that in the past. You could just make calls, and what would happen is when you ran the app, it would crash. Now take a look at this. I went to my program name, and I went and said, I want to read from the console. And now I get this nice squiggle, and it says console.readline is unsupported on the browser. So we now have an analyzer in all the Blazor projects that tells you if you are doing something you shouldn't be able to do because it's just not safe. So that's kind of cool. The next thing I want to show is if I drill down to my app over here, the page that hosts the app is called host_host.csshtml. Let me load that up. And you're going to notice this is the main app that kind of hosts my app here. You see my CSS and all the stuff up here. And then it has a component of the Blazor client app. This is what sticks the Blazor app into the app. But there's a new attribute we've added here. Render mode equals WebAssembly pre-rendered. What this lets us do is it lets us actually generate the first page completely before we actually, as part of the building of the project, which means the app will load instantaneously. So let's run the app. And as I said, we've all seen the single page applications that show the spinner as they load. This loaded instantaneously. If I click here and keep pressing on the refresh, you never see a loading screen anywhere here. And that's because of this pre-rendering. Pre-rendering is pretty amazing, generates this awesome performance. Let me show you another cool feature that's not a Blazor feature. It's actually a .NET feature all up. Let's go back to the source code. Let's go find the index page for the application. Hello world. And I could say instead, hello Codecamp. I'm just going to press save. I didn't rerun the app. I didn't do anything like that at all. And notice when I move back to the browser, the code just changed. So what is new with this? Let's say Codecamp 2020. Save. Alt-tab back to the browser. It takes a couple seconds. There it goes. This is a brand new feature that's in the new builds of VS, and I recommend every ASP.NET customer to try this. It's not on by default yet, but we'll make it on in the future. And if I go to Projects and Solutions, and I select ASP.NET Core, there's this auto build and refresh option. And it's a drop down, and you can see I selected auto build and refresh after saving changes. And what this does is anytime you change the source code for your application, you don't have to rebuild and relaunch the browser. Just press save, alt-tab back to the browser, and you'll see the change live. And this works for all ASP.NET projects. I'm showing it to you in the case of a Blazor application, but it's not limited to Blazor at all. This happens on everything. Next thing is interesting is, let's go and look at a page in the application. This is the fetch data page. And notice it says showing the next basically 100,000 days. So this is a page in a web application that's going to show 100,000 rows of data. And notice it launched very fast. Let's go back to it. It's almost instantaneous. How does that work? So let's go look at the source code for this. And let's look at fetch data. And normally in our previous default template, there would be a for each loop here, and it would basically loop over the collection of data, printing out the results. But I've replaced that for each loop with a virtualize tag helper here. And so for virtualize, what I do is I tell it the method to call to get data, and then tell that method how much data to go get. And then it acts the same way. Basically, it goes and grabs the data and it binds to the screen. And what you can see here is all I do is I have a method here called get weather range, and you can see it wants to get 100,000 rows, and you can see it basically says give me this many, blah 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 blah, and so it goes and returns a certain amount of data. Now let's go back to the browser and take a look at how that works. If I press F12, bring up the DevTools, as I start scrolling, notice these requests are coming in over here on this side. And these requests are basically chunks of data. That virtualized element lets you basically build a page just like you would build it normally. But as you scroll the list, we will actually go and automatically call that method, get the chunk of data, show it on the screen, which means you can now show 100,000 or 1,000,000 rows of data. It doesn't matter. And it'll last forever and be very fast. So it's super, super cool. One of my favorite features in Blazor, something we never actually really did for .NET Web Forms. I'll show one final feature of Blazor in WebAssembly, and this is we have this notion of components. So one of the cool aspects of Blazor is it brings a component model back where you can basically bring controls, and we have control vendors, Progress, DevExpress, SyncFusion, all of them. They all have Blazor controls that give you rich functionality. But it used to be that you would have to actually add the component and then also add a CSS or JavaScript file with it. So if I go look at my, I've got a component down here. It's just a class library, a Razor class library, and you can see I've got this Blazor component is defined. It's got a strong tag here. It's got some CSS. Let's take a look at that CSS. And basically says my component is the big thing here. It's going to give it a background, and this requires some assets. Notice in here, my background PNG is here as well in my component. My CSS is here. The cool thing about what we've done in .NET 5 is if I go use this component in my application, all I do is reference the component. I don't have to reference the CSS or the JavaScript. That all comes with the component. And so I can just go over here. I can uncomment this component. Press save. Let's go back to the browser. And there you go. There's the component. You can see the background images there, giving that style. And so we're making it even easier to build, components. So just to go back and highlight a bunch of cool stuff here. You saw the component virtualization, lots of rows. You saw the pre-rendering, super fast. You saw the CSS and JavaScript isolation, and I showed you that awesome auto updating as you change the application. So with that, let's go and talk about cloud native for a little bit. So this has been a huge push for us in the team for a bit. Done a lot of work here, and what you can see here is we've done a few things. REST APIs. We've had Web API in .NET forever, but we really wanted to go make the Web APIs even better. So Jimmy was just showing in the previous session some of the work we've done with Open API. So Open API is now an option when you build a Web API in .NET 5, and it enables us to do a bunch of cool things. One is it gives us the ability to, what Jimmy was showing is when you launch the application, normally an API wouldn't have any HTML with it, so it would just, you couldn't really control F5 it. Well, now we launch you into that swashbuckle page where you can actually go and try the API out. And that's because the metadata that OpenAPI adds gives us the ability to tool that. That same metadata enables us to also have an API REPL. I don't know if Jimmy showed that or not. I might show that real quick. It also enables us to generate a client by default. The biggest feature we had as we moved from WCF to REST was customers were asking, I want to right click and generate a client. How do I do that? Because WCF just did that for you. We now have that for web APIs. You can make a web API, and then you can build a class library, right click, say you want to generate a client, and we'll generate all the code to call the API. So it makes it super simple. That same metadata enables us to also let you publish, and this is built into Visual Studio 16.8 as well. You can now right click publish, and when you're done publishing to the cloud, you can also have it publish your API to API management if you want to go monitor the usage, put rate limiting on your API. You want to control who can access it. That is built in as well. And then of course there's gRPC, and this is it's very similar to WCF, but it is cross-platform, and it works on tons of frameworks. It works on Go, it works on Java, and that's one of the cool aspects of it. You write a gRPC API, you get the same cross-language benefits that you get with REST, but it's a binary protocol, and so the performance can be a lot faster. And we have the exact same tooling. You write a proto file, that's the definition of your API, and we'll generate the server stubs, and we'll generate the client for you dynamically. And I showed before in the slides, we have world-class performance here. The next thing when it comes to cloud native is smaller, faster microservices. I already showed a lot of the perf improvements that we have in the tech, but we continue to make our container images smaller, single file applications, and top level programs that you write less code. And then I already showed that cross-platform development with WSL and Linux. So let's do a couple things here. Let's go back to VS. First off, I'll close this out in the browser. back to VS, and let's change projects here. And I'll show a little bit of this, and probably show some stuff that you, it's too hidden in our tech, and it's something I want to fix in the future. And so what I've got here is I've got a super tiny microservice written in .NET 5. And first off, it's using a new capability here. This is called top level programs. And so this is the entire app. Notice there's no main. There's no entry point called main. There's no class called program. You don't need to write that stuff anymore. If you want, a C# application can just start. You start in your file and write code. So you can see all I did here is I did some usings and I wrote some code. And this is kind of the smallest microservice you can write. So basically it's a 10-line microservice. And that's one of the capabilities we're working on and we'll continue to work on is letting you write these smaller things. You know, we have MVC and Web API. You can use as much or as little of those as you want. And so this does exactly what you expect. You know, I just goes hello world to the screen. But let's show some of the tech that we don't show very often. If I right click on this and I click publish, I don't have to publish an app to the cloud. I can publish an app locally to a folder. And that's what I have this set up to do. And let's go take a look at some of the options that you might not see. So you can right click, you can select publish to folder. And when you do that, you get a variety of options that you might never think about. The first one is deployment mode. This says self-contained. By default, we are what we call framework dependent. Framework dependent means we expect you to have .NET on the machine somewhere. So you've run the .NET runtime installer or the .NET SDK installer and you have .NET on the machine. But one of the cool things that we did in .NET Core and now .NET 5 is we support self-contained. That means you get a single exe that contains the framework and your application. And we've talked about that a lot, and so some people might know that, but do you know about these? This makes a folder with .NET and your application. There's a new option, produce single file. That then says, don't give me a folder full of stuff, give me a single file. And so you can check that and we'll give you a single file. There's enable ready to run compilation. If you check that, the single file will get bigger or the folder will get bigger, but the app will start faster because we've pre-jitted some of your application. And then my favorite one is there's this new one called trim unused assemblies, and that gets rid of a bunch of the tech that you're not using. So let's take a look at what the output of that looks like. So I've already run the build. And so let's go to, let me grab a, grab a file explorer here. And let's go to my machine. And let's go to Microservice 5.0. Microservice 5.0, bin, release, net 5, publish, and let's take a look at this. Here's my single exe. It's 21 megs in size. It contains everything required for my app to run. I can click that. Notice how fast it started. And this is us continuing to work on getting .NET smaller and smaller and smaller, where hopefully you can build these almost native applications in .NET that are just copy the exe to a machine. And so that's a big push that we've done in .NET 5. The next thing is something called Project Tye. And so Project Tye is something that lets you build microservices, develop and build them faster. And it's in preview or experimental mode at this point, but it's something we plan to ship in .NET 6 next year. It does a couple things. Number one is it's got service discovery. What does that mean? Notice I have my front end application here. How does it find the IP address and the ports of those other 3 microservices? Today you hard code that stuff in config files. When you publish to the cloud, you change the config files. Yuck. So it does that for you. What if you want to develop against SQL Server or Redis? And I give the app to you, and I give you my repo. You don't have those dependencies installed in your machine. Well, with Tye, you can actually define those dependencies in a file, and we will actually just pull them down with containers. So you don't actually have to install any of those products locally on your machine. When somebody's using a Docker container, you can just, when you're done, delete it, it's gone. No impact on your machine. Then you want to run these things locally. We have a feature in Visual Studio where you can right click and say set startup projects and run a bunch of projects. It's clunky. We plan to make that, revisit that completely in .NET 6 and make that much, much better. Not only can we do that, we'll let you run it on Kubernetes locally. So you can actually run on your local machine the same way you're going to run in the cloud, just like I showed earlier with the Linux stuff. And then finally, once you start running more than one piece of your app, how do you measure that? That's where the start all projects doesn't work very great in Visual Studio today. There's not a good way to find the perf counters or do the debugging. You have to set the debugging manually for each of those things. And so we'll give you a dashboard. We'll make the debugging very easy. And then finally, we'll make it super easy to take all those components and upload them to the cloud, whether it's AKS, that's Azure, or whatever cloud you're using. So let's do a quick demo of Project Tye. So this is a typical app I've got here. It's experimental this time. So I'm going to show it to you primarily in VS Code, but support for this will be coming in Visual Studio early next year. And so if you look at the app, let me scroll up here. You can see I've got a front-end app and I've got a back-end app, two apps. If I was going to run those manually today, I might do something ugly like this. I might come over here to my front-end project and say .NET run. My back-end project, say .NET run. You'd probably create a script to do this because it's kind of cumbersome to have to go and run both the front-end and the back-end projects kind of manually. They're both running, but now if I go and grab the URI here, browser. And I publish that. What's going to happen is this is going to crash hard. And that's because my configuration is not very good today. I have to hard code the front end to know the IP address and the port of the back end. I've not done that. And so it doesn't work. So let's just stop these and think about Tye. So let's close that out. Oops. Close that out. And what I'm going to do now is I'm going to go back to the app in VS Code, and I'm going to change it a little bit. First off, you can notice here, I hard coded localhost 222.30. That's why the front end couldn't find the back end, because the IP addresses were wrong. Now, I could go and take the IP address from the other application, paste it in here, and the app would work until I publish it to the cloud. But with .NET Tye, we can solve that. So I'm going to comment that out. And I'm going to go back to my project file, and I'm going to include a reference to, there you go. Let's do a restore. And this is just a package that adds some new capabilities for Tye to my application. This will be built in when we're done. But it means now I can go to my app, and what I'm going to do is I'm just going to say, instead of hard coding an address, I'm going to say get service URI and give it the name. The name is based on the name of your project. So if the front end wants to talk to the back end, it basically says get service URI for the back end. Press save. And now what I can do is I can go back to my command prompts, and instead of doing those .NET runs, I'm just going to type Tye run. And what this is going to do is it's going to go find all my projects. It's going to launch them, and it's going to launch me a dashboard as well. So I'm going to grab the dashboard here. Back to my browser. And I'm going to launch this dashboard. This is a new feature. I think it's amazing. So now because we have more than one app running, instead of just launching the app, show me all the apps. So here I am seeing all my apps. We know their projects, CS projects, so we call them that. Here is the local host and the port. All the magic is right here. I can click and view the logs. I can view the logs from both sides. I can click the app and see the front end. I can see the metrics, perf counters. So I get some awesome information. And if I click the app here, now it's going to actually find the back end, and it all hooks up and it's good to go. That's kind of cool. Let's take it to the next level. Let's use a dependency. So I'm going to go back to VS Code and stop that. I'm going to go back to VS Code, and now what I want to do is I want to make this app use a cache. So To do that, I need to do a couple things. I'm going to type Tye-init. And what that's going to do is that's going to create a file for me. And that file basically is a description of my app. Notice there's the front-end project it found. There's the back-end project. And what I want to do now is I want to go add some new stuff to that. So I'm going to go and grab a little bit of Redis magic here. I want to add a Redis cache, which, by the way, doesn't run on Windows. And so this is something that would require Linux. But I don't need to worry about this anymore because I'm going to use a container. So in this case, instead of calling it a project, it switches to use image, which means container image. And I give it the name of my image and a couple of config settings. So I'll save that. Let's go back to my let's go back to my CS proj. Now, because I'm going to use Redis, I need the Stack Exchange package for talking to Redis. Bring that in. I need a dependency injection Redis into my application so my web page can see it. And once again, the same technology you saw before. I don't worry about ports and IPs. I just say get connection string and give it the name of the service, and I'm done. And then finally, I need to go back to my main app, and I have a tag helper here called distributed cache. It's built into .NET, and I'm going to put my whole app inside of this tag helper. And what the tag helper does is it says give the cache a name and say I want this to work for 5 seconds, which means anything inside of that block is going to be cached for 5 seconds. Okay. So I'll go back over here again, and I'll do a Tye run. And once again, Tye is going to recognize that now I need a container. Oops. Before I do that, it would be helpful if I went over here and I ran Docker desktop. I'm going to start running containers now, and so it's super important that I have Docker running. Let's give it a second here. You can see it booting up. It says Docker is starting. Come on, Docker. Okay, Docker is now running. So I can come back over here and I can say Tye run. And you can see it already failed before. It's like, drats, run failed. And so what's going to happen is we're going to boot up the front end app, the back end application. It's going to recognize that it needs to run a container for that Redis cache. It does all that work for me. I don't have to worry about knowing Docker files, running Docker commands. It's all running again. I can go back to my browser, refresh that dashboard. And now you'll notice that there's a container running there with my Redis cache. I can click my front end application here. It runs exactly like it did before, but now as I refresh the browser, only every 5 seconds do things change. So now I've got a third-party dependency. It's all wired together. Now let's do the crazy final piece of this magic. And let's go back down here. And I'm going to type Tye deploy. I want to make all this stuff go to the cloud. That's my front end, my back end, and even my cache. So I'll tell Tye to deploy. And it needs to know my container registry. It needs to know where am I going to put those containers in the cloud. So I've got a dashboard here. Let's go to the dashboard. Let's grab my registry. Grab the URI for that. Paste it in. So it's going to take all my containers. It's going to publish them up to that registry. And then, oops. And before I do that, let me stop. I want to do one final piece before I do that. I want to make sure that you can even call this from your machines. So let's go back to VS Code. Let's make one final change to my Tye file. And I'm going to create what's called an ingress. This is basically the front end. So there's the front end app, the back end app, my Redis cache, and I need a proxy that I can actually hit. So you can see here it's called ingress. Here's the port, and it basically takes that port and maps it to the front end here, the front end project. So let me save that. Let's go do that Tye deploy one final time, and then we'll talk about .NET 6. And grab that from my portal again. This stuff by hand. So now it's going to take those two containers. It's going to publish them up to that container registry, which is tied to my Kubernetes. It needs to know my Redis. And so what's going on here is I was running Redis locally in a container, but Azure has Redis as a service. So it says instead of running it as a container, let's run it as a service. Let's go back to my dashboard. I've got my Redis sitting right here. I'll click access keys. I'll grab that connection string. I'll paste that in. There we go. And I can say cube control, get ingress, return no address because it's actually still populating a little bit. I'm going to let that sit, and I'm going to go back to finish the slides, and then we can come back and show the final result of that. So going forward, you know, with the pandemic this year, we didn't do all we wanted, but we want to take. We have this today. We have .NET Framework, .NET Core, and Xamarin. We want to take the best of all of those, merge them together, call that .NET. We have .NET 5 today. That's a single SDK, meaning that all the workloads, mobile, web, desktop, console, class library can all be done through one SDK. Today we have all of those except Xamarin. Xamarin will come in .NET 6. We want one BCL. I mentioned this before. All your .NET apps use the same BCL. Now your Blazor Webassembly apps use the same BCL. And with .NET 6, your Xamarin apps will use the same BCL. We want to have a unified tool chain. You know, that new CS proj that we have that working for all the project types today, except Xamarin. Xamarin will be in .NET 6. And with that, we'll have awesome cross-platform native UI with .NET MAUI using our Xamarin tech. We're going to have awesome cross-platform web UI using ASP.NET and Blazor. We're going to have awesome cloud-native investments, meaning the best REST, the best gRPC, the best way of running services with Tye. And we're going to continue to make you know, .NET faster, smaller, and I think that at the end of .NET 6 we will have the best breed solutions for all the modern workloads you would build. So .NET is a one-stop shop for everything you want to build. We just shipped obviously .NET 5, sorry, in November of this year. .NET 6 will come out November of next year. We ship now .NET on an annual basis every year, and then every other year is what we call a long-term support release. And this is designed to be predictable and easy for you to understand. And as I said, .NET 5 is available today. VS 16.8 is available today. Get them both. Start trying .NET 5 and give us feedback. And then, you know, thanks for joining. You can always find me on Twitter at @coolcsh and ask me some questions. Before I jump back and answer any questions, I do want to go back and run this command one more time. There's that port. Let's grab that. Let's go back to my browser. There is that multi-part application with the Redis cache running inside of Kubernetes in the cloud. And if I keep refreshing it, once again, because it's using the cache, it only updates every couple seconds. There you go. And so with that, I will stop sharing my screen and answer any questions I can answer real quick.
Thank you so much, Scott. So let's brace ourselves. It's going to be like a long Q&A session looking at the list here. I'm going to start now. So the first question is, how does the ASP.NET Core and the .NET adoption in general looks like now compared to maybe 5 to 10 years ago? What's happening? What trend? If you look at .NET and ASP.NET together, we are growing faster than we've ever grown before. You know, if you look at like, let's say a competing technology, the assumption is there's 9 million Java developers in the world, and we are at 5.2 million. So we are at a very quick pace to catch Java, being one of the most used frameworks in the world. It's hard to actually measure anything other than us. We can measure .NET better because we ship the tools and the frameworks, and so it's hard to, you know, if you ask me how many Node.js developers there are, it's actually very hard to actually ascertain that. But our growth numbers, we've been growing 1 million a year, and I think we're actually accelerating. So we are very, very excited with that. ASP.NET
is the most used workload in .NET and .NET Core both, and it is accelerating very fast as well. Blazor is the fastest growing workload in .NET, so it's growing at a crazy rate. We actually have, Blazor's only been out for a year. We already have over 100,000 Blazor developers.
That's great.
Well, yeah, that's very cool because since you mentioned Blazor, when I talk to people about this, yeah, there are some that are really excited about the technology, and it's like me because my go-to language is C#. So although, yeah, Angular and React are good alternatives, but yeah, I feel most comfortable doing things in C#. So I love it. But then there are other people who are not so excited because they want to see, okay, how will it grow, and see that, wait to see if it's exactly on the same level. And let's say, I even heard this once, I want to see if it's not a new Silverlight.
Right. But since you mentioned,
the Silverlight question is a valid question. Silverlight. Well, first off, Silverlight lives today. For people that don't know, .NET Core and now .NET 5 are actually based on Silverlight. Silverlight was the cross-platform version of .NET that we built before. Silverlight primarily died because browser plugins are dead. You're all aware that I think Flash, the most commonly used web plugin on the planet, it dies in 4 days. And so I think all the major browsers, stop. And so I don't think we'll be Silverlighted because I don't see web dying. And I don't see Webassembly dying. I don't see any of the technologies that Blazor is built on going away anytime soon. I mean, if Angular, React, Blazor, Vue all disappeared, I would be stunned. But Silverlight unfortunately died because mobile devices came out, and mobile devices did not want to support plugins, and that was kind of the beginning of the death of it. And then if you look at the sandboxes that browsers have today, they're way more safer than having a native component that runs with full access to your machine. And
right.
That's why Flash is dying.
Right, and also what sometimes we don't realize that easily is that, yeah, the things that are live today and that we use, they started a journey years ago with different components that all came together.
Back into 2013.
Yeah, right. like you're saying. But about .NET, if you look at the kind of problems, let's say, that you're solving now with .NET today, how are they compared to 2 years ago or more? Are they different? There are different challenges.
Always different challenges. Like the next problem. If I think of .NET 6, like if you ask me what are some of the big things you're going to work in .NET 6. We know that we have best of class runtime performance. If you build an app in .NET, whether it's a desktop app, whether it's a mobile app, whether it's especially if it's a web API or web app, we offer best class performance. Our gRPC numbers are better than anybody else's. But where .NET isn't as good, we're not as good when it comes to what we call developer inner loop. And that is, you change something in your code and you refresh your browser. How long does that take? If you're using Node.js, that might take sub 1 second. If you're using .NET, you saw today on my machine, I would press save in the browser, in Visual Studio, Alt tab to the browser, and 1,1000, 2,1000, 3,1000, click. So that'll be an area you will see a huge amount of work that we'll do in .NET 6 is getting to what we call inner loop performance better, because we know we're better at runtime, but we want to be better at design time as well. So that'll be a huge area that you'll see us invest in. Another area that some of the languages like Go and Rust, they offer one of the nice capabilities they offer is they offer very small executables, 10 megs in some cases, and we don't necessarily want to compete with that, but we want to be in the ballpark. And so you saw we made a whole bunch of journeys in .NET 5 where we got small ASP.NET applications down to about 20 megs, 20 to 23 megs. Where that breaks down is if you start using more and more of the stuff, obviously the app gets bigger, and that linker technology can also make your app break. and make it brittle. You might not realize you're using reflection to load something, and so the linker throws it away and it doesn't work. So we'll continue to work there to make these self-contained small executables better. And then I think another area that .NET can always get better in is startup time. Even though we run great once we get booted up, we're not always the fastest tech to boot up. Both Java and us have that challenge. So those are three areas across the board that we will deep dive and focus on with the tech.
And .NET 6. Cool. And since you brought it up, because there is a question about this. You showed that feature about deployment where you can trim unused or necessary assemblies. And the question is, how does that work with the reflection?
It doesn't. So, the way that tech works is we analyze your project, and if we don't see any links from your project to some other assembly, we will kill the assembly. In .NET Core 3.1, that meant ASP.NET didn't work because ASP.NET uses lots of dependency injection, which is reflection. But what we did in .NET 5 is we went and attributed all of ASP.NET. So now ASP.NET is more linker friendly. We will continue to make apps more linker friendly. Now, let's say we do blow you up. All you have to do is go to your project file and put a reference to the DLL or package that we linked out. And if you manually reference it in the CS project file, we will not link it away. Now, what I want to do in the future is I want to have better tools that when it crashes, help you figure out what missing thing caused the crash, and maybe I actually hint you or tell you right-click, just like you can control dash or control dots to go fix some of your code. I can do the same thing and go put a reference into the CS project for you to bring that reference in.
Yeah, correct.
I see there was a question about Winforms and WPF as well from Victor. And I want to address that one. And that is WPF. Winforms is built by my team, and we did the work to get it open sourced and be able to take contributions on it very fast. In fact, unknown to a lot of folks, .NET 5 actually contains third-party controls that were actually submitted to us in GitHub. So we've actually added new stuff to Winforms. WPF is not there as fast. So the WPF repo has some challenges where we don't have all the tests running yet for it in the public repo. We hope to have that done, if not now, early January. And then the next thing for WPF is we also are porting WPF to work on ARM64. And so you're going to see the repo get cleaned up where we can take pull requests from the community, and you'll see the ARM64 support come next.
Okay. Someone is curious if Xamarin played any specific role in .NET Core, construction of .NET Core.
Dapper?
No, Xamarin. Did it play any specific role or?
So Xamarin is a huge piece of .NET. And we haven't, our original plan with Xamarin was to actually have it be part of .NET 5. And then the pandemic hit, and we realized we couldn't do everything under the circumstances. And so Xamarin will become part of the .NET SDK in .NET 6. And a bunch of cool things are going to happen here. Number one, Xamarin will be in .NET 6. Xamarin is going to move to the same BCL, base class libraries, that the rest of the .NET workloads use. I'm super excited about that. And then one of the most exciting things that's going to happen in Xamarin is there's this notion today, everybody's heard of this, hybrid applications, hybrid web apps. We've all run, well, we're in Teams right now. Teams is a Electron application, so that's a native app that hosts a web view. And so we plan to add a Blazor app, a Blazor tag to Xamarin. So you'll be able to build a Xamarin app in .NET 6 that actually hosts a Blazor app inside of it. So it lets you take a Blazor web app and then host it as a native app. And you might ask, well, why would I want to do that? And there's lots of reasons you want to do that. Number one is it makes it easy to install. Number two, it means the app, because it's a native app, can actually talk to native things like the microphone or the file system or whatever. We had a customer that runs a dry cleaning business, and they rewrote their entire app in Blazor but the app needed to have access to the cache register. It needed to have access to a display board. It needed to have access to the thing in a dry cleaners that makes the clothes spin around on those rails. And so they took the Blazor app and hosted it inside of WPF with the web view, so they had access to that local tech. We're going to make it where you have a Blazor web view tag in your Xamarin app, and you can easily merge the text together. And so I think that's going to be super exciting, giving people a hybrid desktop app, with Xamarin and Blazor.
And since you mentioned customers, I'm going to deviate a bit from the list of questions and ask you that, like I said, sometimes we don't realize that a framework, a platform like .NET it's still a product, and it's a huge product. And then when you, let's say, plan out the next year and what the roadmap is, what sort of things do you take into account? I mean, maybe technology trends and then feedback from.
We look at both technology trends. We look at feedback from customers. We look at competitive analysis. That's where that inner loop thing that I mentioned before comes from. We look at all three of those. Something that we also want to look at in the future. We started having conversations this November. Is we are also asking. We have a technical steering group in the .NET Foundation, and it's made up of a bunch of partners. There's people like Amazon's in there, Google's in there, JetBrains is in there. I'm leaving out, I'm sure, plenty of people, so don't get mad at me for leaving you out. But we want the foundation to have input as well. So we want to have input from our Microsoft Independent Foundation. It's competitive research, what customers are telling us, and what technology trends are happening are kind of the four things that we look at. And I don't have the URL with me right now, but I can send you afterwards. We have a published list of all that stuff in GitHub that anybody can access today. So we're trying to be more transparent and open, so the planning is something that everybody sees. It's done in the public. It's not done, private, like it would have been 10 years ago.
Yeah, behind closed doors. Yeah, I think this is really awesome. Back to Florin.
Yeah, we've got a couple of questions regarding the auto refresh feature that we've just shown. The first one is if it's working with Angular, and the second question is how did you implement that? How is this working? How does that impact the performance of your computer?
It won't impact the performance of your computer at all. We've had various flavors of tech to let us do this for a long time. So, kind of what happens is you make a save, and by the way, I should say that feature works both from the command line and inside of Visual Studio. So if you do a .NET run from VS Code, or you do a build inside of Visual Studio, it works in both of those technologies, or both of those ways of hitting .NET. And literally all we're doing is we detect a change, and when we detect that change, there's a little snippet of JavaScript running inside of the app that lets us basically do a push to the app, telling the app to do a pull again and to repull. And this is something you'll see us standardize across. Our hope is, and once again, this is a .NET 6 thing. We want that to be for all apps. So if your WinForm app, we want it to work in WinForms. It already works in WPF to some extent today, but we think this is, and it works in Xamarin with the hot reload that we have. But we look at this as a thing that we don't think is not just a web thing. We think it's a .NET thing, and we want all the apps to have that. Change the code, see the refresh. It's what we're seeing, and if you look at things like Flutter and other languages, it's the way developers are working today. It's one of those things you were asking about developer trends. This is a developer trend, and we're making sure that .NET does well in developer trend. I have to thank Damien Edwards on my team. This feature literally showed up in like 2 previews before the last 2 previews in .NET 5 before we RTM'd.
Cool. The other question is, what do I need in order to deploy an iOS app directly to the phone from Windows? Is that a new version or can be done now as well?
To deploy iOS?
I don't know. It looks like iOS.
Let me see if I can see the question in the published list. Because iOS is part of Windows. You don't deploy iOS. If you're looking
for iOS, it's iOS.
Oh, so to deploy an iOS app from a Windows machine to an iPhone or something like that?
Yes.
Yeah.
So it's super simple. It requires two things. I thought you were saying IIS. All that's required for that to work is you have to have iTunes installed on the Windows machine, because iTunes is the gateway that we can talk to the device. And you also have had to go onto developer.apple.com and created a free developer account. Once you've done those two things, literally all you do is you plug your iPhone into the PC while you're sitting inside of a Xamarin app, and we will detect the iPhone, and we'll walk you through the wizard where you basically put your developer account in, and that's pretty much it. As soon as that happens, in the drop-down list, like before, I was showing you running on either IIS Express or WSL2. That same drop-down list you'll drop it down. Your iPhone will show up in the drop-down list. You click your iPhone. That will cause the deploy to happen to the iPhone for the first time. It does not require your iPhone to be in developer mode or any weird stuff like that. It's literally just plug the app in. And then what's even cooler about the technology is then once you make a change inside of Visual Studio, we don't redeploy all 50 or 60 megs or however big your app is to the device. We only deploy the diff. And that's really impressive too, because once you get it running the first time, it boots up really quick. After that, every change of code in Visual Studio just takes a second or two to get to the phone. And it's really amazing. We plan to bring that same tech to Android as well. Android just works, with an emulator or with an Android device, but we want to do that same diffing tech to make once again, it's inner loop. Make a change, it gets to the device as fast as possible.
It sounds like some of them can be regarded, small tweaks that improve the developer's life, but I guess there's a lot of work behind them.
There's a lot of work. That iOS thing took us over a year, I would say, to get really working. I mean, it worked partially for a long time, but it's really stable now.
I mean, at some point we just see a checkbox or an option in Visual Studio, but there's a whole journey behind that.
I should have demoed that today. It's an amazing demo. It's if you've not seen it, it's the first time I got it to work on my machine, I was like, wow, phone development does not suck anymore. Because normally you're running an emulator and you have to copy frameworks and stuff. Whether you're doing Android development outside of .NET, the inner loops just aren't very good. And so it feels like a game changer to me.
Another question would be if we can expect support for ML.NET for ARM CPUs anytime soon.
ML.NET for what use?
For ARM CPUs.
ARM?
Yeah, ARM.
Ah. So that the question really is ML.NET. When are we going to make it work on other architectures other than just x64 and x86? ARM support is on our backlog. We obviously want to get ML.NET running on the iOS devices and the Android devices, and we want to get it. ARM is once again. Let's talk about technology trends. Back to one of your other questions. That ARM is something that we definitely see as a huge technology trend. We already had ARM32, ARM64 support in .NET to this point. We decided Windows ARM support. We're going to add Windows ARM support for Winforms and Wpf pretty soon. Amazon just recently showed they have a blog post showing that .NET 5 running on their ARM tech runs faster than some of the Intel tech, very similar to the Apple M1 stuff. And so ARM is super important for us, and we want to make sure that we get ML.NET fully running on ARM.
Cool. And yes, ML.NET is also another piece of work that I'm really excited about. Like I said, it brings this part of machine learning in the .NET ecosystem.
ML.NET's amazing. ML.NET was, for folks that don't know, ML.NET is technology that already was built into a bunch of Microsoft products before it was ever shipped publicly. If you do Windows Hello, which is the thing where Windows can recognize you and sign you in based on your face, or if you're in PowerPoint and it recommends designs for your deck, Those are two examples of ML.NET in action. ML.NET is growing at a very fast rate, which is amazing and surprising because ML.NET's not simple, and it's kind of niche, but it's growing at a great rate, and we're super excited with it. And so, there's a whole lot of exciting stuff coming in ML.NET.
Right. I'm looking now at the latest questions. There's one about native Windows apps. I'm paraphrasing here. Testing native Windows apps has always been a challenge. Are there any new features? Specifically, what features are there in .NET regarding WinApp driver?
So what aspect of native apps do they?
Testing them.
I'm trying to find it because I don't understand the question. Testing native Win apps has always been a challenge. Any new features, specifically what changes, improvements are there in the .NET Win app driver? I would just ask you to please ping me on Twitter at coolcsh, and I think I need more details to know what you're driving for. I'm happy to help answer the question, but I'm going to need more details. So.
All right. Yeah. Hope you is listening now. And all right. The following.
Actually, reply back and say that too.
Let's do the last one. It's been a long Q&A session. Thank you for that. But the last question would be: can we expect C# evolve with more functional type of language?
Some of that's happened already. If you look at some of the changes in C# that we made in C# 8 and 9, some of them are bringing the best of functional to C#. Obviously, we have, if you want full functional, we have F#. And so, the goal is never to make C# into F#. So if you want full functional, please try out F#. But, just as we've been talking about, C# is something that we always are looking at. What's the best tech, whether it's from functional languages or from non-functional languages, that we can bring into C# to make C# more productive. And a lot of stuff that you've seen recently is stuff that lets you just write less code. We're trying to walk a fine line of letting you write less, but not making it look like a pile of symbols or something crazy. Some of the other languages look really, terse, and so we're trying to find a right balance. I mean, the record stuff I showed today is super clean.
Yeah, I think that's important because sometimes, it needs to be a balance. I mean, it also needs to be readable, and then you or others in the team should be able to understand easily what's going on. And then, speaking about this, I also had let's say, more of a question for you on day-to-day work. I mean, it is one .NET, or it will be, but then it's a lot of smaller products in the .NET. How difficult or how easy it's for you to do this context switching? Isn't it a nightmare?
It gets easier and easier every year. So if you go back in the full history, go back to .NET Framework 1.0. That was a very easy product for Microsoft to work on because it was one team. And then what happened to .NET was .NET got chopped up into pieces, and I told you before, I joined the ASP.NET team. And I was working on ASP.NET when I was not even part of the developer division, the group that builds .NET. The networking team, which started off being in .NET, moved to Windows. Xamarin was an acquisition that we brought in, and that's just a few examples of pieces of .NET. And so what happened with .NET is it got spread all around Microsoft. And then as we started doing the .NET Core work back in 2016. We've slowly been reacquiring all the bits. Like ML.NET was written by a different org, but it's now owned and built by my org. And so one thing we've done is we've consolidated .NET back into a single team. And so the unification, we talked about unifying .NET back into like a single product that works cohesively. That's both the product that you can download and use. That's the way we talk about it, and it's also the way we've actually structured our own teams. And as we've kind of rebuilt .NET back into a single team again internally, it makes it easier for us to context switch across all those things. most of my day work is focused on the areas that we are trying to do the biggest investments in. It's like hybrid web applications would be an example of something that I have a lot of passion about. Getting the Xamarin Tech to work great on Windows and Mac on top of iOS and Android is something that I have a lot of passion about. Making the Windows backend for that Xamarin Tech be the new WinUI 3 tech that the Windows team is building. Those are some examples of things that I do. And then there's, there's whole new categories of apps that, if you're not paying attention, there's Power Apps is something that we have inside of Microsoft. I believe in the Salesforce org, they have a framework called Lightning, which is very similar. These are kind of low-code solutions. We want to make sure that those modern low-code solutions, you can back those with .NET. So a lot of the work that we did in the API space around OpenAPI and publishing to API management, that was all to enable to make all of our developers more productive, but also to make it being able to tie .NET to a Power App easier as well. So we're always looking at those kind of exploratory parts of, where other parts of Microsoft are as well, and trying to make sure that .NET has a place there too.
Cool. Yeah, it's been really exciting. I feel that we could talk for hours about this, and we would like to. But we're definitely going to extend another invitation next year, and hopefully once also to come to Romania, and we're going to be able to do in-person events. But until then, thanks a lot for the session, and yeah, having the time to answer all the questions. It's been very exciting.
We're looking forward to have you next year in the online events, or yeah, perhaps or hopefully in person. That's what we're aiming for.
I think if it's late in the year, it'll be in person.
At the earliest, probably. But things work like that as well. We're adapting, and yeah, life doesn't stop, and we need to keep learning. That was the motto of this edition.
Keep learning. Keep learning.
That's part of being a developer. I mean, as developers, that's what makes our field so amazing. Is that it's not the same thing we were doing 10 years ago. It's always changing, always new. And so I think as developers, we have to be adapting all the time to all the changes.
Yeah, and at the same time, we're privileged to this, because yeah, it's something that always gets more and more interesting.
Right. So thank you, Scott, and well, see you next time.
See you, folks. Thank you very much.